Okay, lesson 50 is about solving trigonometric equations, and you really need to know your unit circle well to do these problems because you're kind of going backwards where now you have the ratio and you're trying to figure out what angle has that ratio. So, for example, this equation says sine theta equals 1 over the square root of 2, and you are looking for all the values of theta between 0 and 360. That would have a sine of 1 over the square root of 2. So you have to know your unit circle for that. So if you just jump over here and take a look at your unit circle, you can see that 1 over the square root of 2, that is square root of 2 over 2, also you can think of it as. That's going to happen at 45 degrees and at 135 degrees. At both of those places, you're going to have a positive sine function, and it's going to be 1 over the square root of 2, or in other words, square root of 2 over 2 if you rationalize it. All right, so the only possibilities here between 0 and 360 where you can have a sine of 1 over the square root of 2 are going to be theta equals 45 and 135. So those are the two angles that will work in this equation. In other words, if I put in 45 for theta, this makes a true statement. If I put in 135 for theta, it makes this a true statement. So that is why these are the solutions of this equation, because these values, if you put them in here for theta in the equation, you get a true statement. All right, and those are the only possibilities for theta between 0 and 360. All right, here's another example. 2 plus square root of 3 secant theta equals 0, where theta is between 0 and 360. So now we're looking for every angle between 0 and 360 that will make this equation a true statement. Those are the solutions. All right, so the first thing we have to do is isolate the trig function. So we're going to subtract 2 on both sides, and that's going to leave us with square root of 3 secant theta equals negative 2. And then we're going to divide both sides by the square root of 3 so we can get the secant theta part completely by itself. So secant theta equals negative 2 over the square root of 3. Now, we would rationalize that by multiplying the top and bottom by square root of 3 usually, but since we know that secant is a reciprocal function for cosine, we'll just go ahead and rewrite this equation in terms of cosine because I'm more familiar with cosine than I am with secant, especially on my unit circle. So if secant theta is negative 2 over the square root of 3, that means that cosine theta is just the reciprocal of that. So just flip it upside down. All right, so what angles have a cosine of negative square root of 3 over 2? Well, let's look at the unit circle. That's going to happen right here at 150 degrees. And it's going to also happen at 210 degrees. That's where I have a cosine of negative square root of 3 over 2. So 150 and 210. So those are the values for theta. Theta is 150 and 210. Those are the two values that make that equation a true statement. All right? Because cosine 150 is negative square root of 3 over 2, and cosine 210 is negative square root of 3 over 2, and those are the only angles between 0 and 360 that have that value. All right, here's another example. We need to first of all isolate cosecant theta. So we're going to subtract 3 square root of 2 on both sides. Okay, this is just like when you first started learning how to solve for x. You had to isolate x. Well, now we have to isolate the trig function. We can't isolate theta because you can't get that argument away from cosecant, but we can get the cosecant theta by itself. So this would leave us with 3 cosecant theta equals negative 3 square root of 2. And then we're going to divide both sides by 3 so we can completely get that by itself. So that's going to be cosecant theta equals, and these 3's cancel, so I just end up with negative square root of 2. Now I don't have my cosecants on my unit circle, so I know that cosecant is the reciprocal of sine. So if cosecant theta is negative square root of 2, then sine is going to be the reciprocal of that, which is negative 1 over the square root of 2, which is also negative square root of 2 over 2, however you like to think about it. But where does that happen? What angles have a sine of negative square root of 2 over 2? Look at your unit circle, and you can see that those are going to be below the x-axis where sine is negative. They're going to be the 45-degree angles. So it's going to be 225 and 315. So theta is going to be 225 and 315. Those are the only values between 0 and 360 where you have a sine of negative 1 over the square root of 2 or negative square root of 2 over 2. They are related to the 45-degree angles.